Hello and welcome back to this Unreal ArcVis webinar series. So today we are going to look at workflow in this webinar number 2. So we're going to look at some of the projects we saw last time, except we're going to dig a little deeper into the workflow. I'm just going to start by looking at our these two workflows, the V-Ray, what I call the V-Ray workflow, and the Unreal workflow. So the V-Ray workflow really mean we're working with an offline renderer like V-Ray, Corona, Mantle Ray, so on. And I'm just going to compare that with this new workflow, which is Unreal, which is real-time and interactive like we said last time. So let's have a little look at this V-Ray ArcVis workflow. This is all stuff that we're more or less familiar with. We've got the 3D model that we will have either model in Max or use from a CAD software like Revit. We bring that over to our, we bring the materials over, nothing fancy, we just do our textures, your Photoshop for any tiling and so on, and then bring in the lights. So in the case of V-Ray, we use our area lights, our environment, sun, skylights, and so on, image-based lighting, GI, and that's all within the tools provided by V-Ray, and then we render that out. And we create our masks, passes, Z depth, and so on, and then we'll do the post-production in Photoshop or After Effects if we're doing animations. So that's all very familiar, and we will take that over into Unreal. And obviously we're kind of inventing the wheel, as it were, because Unreal, as you know, is made to create video games. So we're kind of trying to cater. The workflow is obviously somewhat different for video games, so the idea here is to try and map something which will be as familiar to us as possible, so we can just really jump on and use our familiar steps. And so a few things to say about this slide here. First of all, I've made this funny symbol here that we are looking at this workflow, and it's going to be heavily front-loaded in this first quadrant here, where we're really looking at how we bring data into the engine and how to do so the most effective way. The reason why we're not going to go into so much depth into the other subjects is that because we are going to have other webinars on where we'll dig specifically deeper onto the lighting, and then we're going to have another webinar about materials, talking about Substance Designer in collaboration with Allegorithmic, and we will also we'll talk about post-processing the lighting, and we'll also have a webinar on VR. So stay tuned for that, so that you know when to log on if you're interested. So again, we'll just to go back to the title here. We've got Unreal Final Pixel. So what does that mean? Unreal is dedicated to creating the final pixel on screen. So that means that it's trying to encompass the much more of the workflow that we will be dealing with when just with V-Ray, for example. It might stop about here just before the post-process, which is typically done in other applications. So here, Unreal is trying to span over the entire process, and even beginning to do some 3D modeling currently. So this is very interesting for us, not having to move from package to package. So let's start at the beginning of the 3D model. We'll have our similar data coming into CAD, from CAD to 3ds Max and so on. And then we've got some new terms like light map UVs. So if we're coming from visualization or from architecture, light maps is something that is going to be very new to us. Light mass, when we move on to the lighting, we've got new skylights. So this new term, which is light mass, which is the GI, the global illumination of Unreal, and then we move on to our materials, and here we've also got a new material editor with nodes. We're using obviously textures, which not only can be used with Photoshop, but also, like I said before, we've got the introduction of Substance Designer, which is a new tool in the arsenal. And then the post-process, which is mainly the post-process volume. So we'll look at that very quickly. And then the interaction we really will barely mention because it's at the end and there is a lot to go through. So let's carry on. So our 3D modeling for real time. As you see, I've kept my little timeline to keep us situated where we are. So what we need to consider when we model for real time, where our data is coming from. Obviously, the CAD software, Revit, AutoCAD, SolidWorks, Rhino, SketchUp have different priorities than visualization software, in the sense that, for example, Revit are primarily concerned to creating 3D models to go out to manufacturing, like Rhino, where so the optimization of the polygon count on screen will not necessarily be optimized, and it will be heavily loaded with metadata and all sorts of links and XREFs and all that. So we can move the data directly from the CAD software to Unreal via FBX. So that's our option 1. And option 2 is to manage this data via another 3D app. So in this case, it's 3D Studio Max, because that's what I use, and this is what I assume most people will use. However, you can absolutely use any other app like Cinema 4D or Maya, any 3D app that's generally geared towards visual effects, film, advertising, or gaming, because this is the apps. These are the apps that will really give you full control over your polygons and the gaming workflow. So from 3D Studio Max, then we will use again FBX to load onto Unreal. So just to jump straight into an example, I've just I just wanted to show you how it works loading and models straight from SketchUp. Slightly brute force here. I just exported one FBX out of SketchUp, and it's looking pretty good. Everything came in. It's in the right place. It's upside up, and it's kind of standing on the ground. And so, just to demonstrate that it works, it's a clean import. All the objects, the furniture are in, and then they're all the right place. But we have got a very high number of objects, and they're all named out of the FBX file with an extension and a number with increased with a number at the end. I'm looking for a word, I can't seem to find it. Anyway, wrong naming and very high number of objects. So that is going to make our life very difficult in the future. If we want to keep working with this file, it's going to need a lot of renaming inside of Unreal, and that's going to be a bit tedious and a bit of a waste of time. The other thing that we've got specifically in this file is the wrong light map settings on the curtains, and we also have these wrong normals with the faces are facing the wrong way. So that's not very good. There's plenty of ways to dealing with that inside of Unreal, and after a little bit of cleanup, everything seems to be looking fine. But I would say that the proper way of doing this would be to export multiple FBX files, at least, to separate the outside from the inside. The furniture should be done individually perhaps, or at least as a different file, and the elements should be separated as much as possible to allow management in the future if you're going to do it this way. However, it's very quick and it's very valuable in the design process, in the architecture workflow, where we want to do quick previs, concept design, massing studies, light studies, and to study views, for example, for large urban projects. So it works, it's very quick, and it works very well. Now, the second option is going to go through 3D Studio Max, and so obviously we can use FBX, but we can also, of course, a lot of the time we get 2 DWGs that we have to model from, so then all the modeling will be done in Max. We've got OBJ, OBJs, PDFs, and so on. So what's the advantage of going this way? It's the professional workflow. I don't think I have yet to meet any professional or agency or freelancer that doesn't go through Max. We are able to have clean geometry. We are able to manage the files, to manage any design changes or back and forth with the client. If you remember last time we talked a lot about real time, so here we need to Nreal is really sticking to this real time, and in order to achieve that, we will probably need to optimize our models. So the problem obviously is that 3ds Max is expensive, and it's a pretty big software. So if we don't know it, and if you're thinking of getting onto this, I think Blender is a really good, interesting option to look at. I'm certainly going to spend a little bit of time on Blender. It sounds very interesting. Anyway, 3 steps that we will go through when we take the data in. Number 1, we check the geometry, check that everything's there, and just do a survey of the quality of the data we've got in. This is something we probably would be doing anyway in our projects, and we will need to reorganize the file. I'm going to go talk about that in a minute. Number 2 is we will apply light maps UVs. So we'll talk a little bit more in detail about light maps, and then we will export. So in order to do these 3 steps, we need to have a little bit of strategic thinking, because I brought in this file, and I would like to mention Tilt Pixel. Thank you very much for letting you use this model. And here, as you can see, the file came in with all these BIM-like names coming from Revit, and they all, in this instance, came in all on layer 0. So I had to reorganize the file by layers. If the file comes in with layers from DWGs, for example, you are most likely going to inherit, whether it's this file's CAD layers, but also any XREFs, any files referenced in to that file will also bring in its own layers. So it will probably end up being very complicated, many layers, and will need to be reorganized anyway. So I would recommend to spend a bit of time thinking about how to approach this problem, because it will come in very useful in the future. In this case, I like to separate everything by material, and that comes in very handy when we can do that, and then separate again by smaller materials. So remember, we've got to check our geometry, apply UVs, and export. So every time we can use a combination of hide and freeze to know what we've applied our UVs to and exported. So a little bit of getting organized here, and so obviously 3ds Max is the ideal tool for that. So here, let's jump into the UI. I'm going to show you 2 things So let's jump in. I'm going to do my disappearing act and then start that up. And well, I was going to show you this little SketchUp one while we were, why don't I just do a little run around while we wait for the other one to start up. But yeah, the SketchUp ones come very clean and no major problems. So that works really, really well. In order to fix this problem, the two-sided, I just made that material two-sided. So that was pretty easy. Okay, so I can exit of this one. And then I will import my Robin Hood. Pause while that's... Okay, so here we are in the interface with this building. So first of all, I'd like to point out that this is done using the preview technology that Chris is going to show you at the end of the webinar. And you can see that all the name came in properly as per as the name they had in the original Max file. It wasn't the name of the FBX with an append. It's the proper file, and so this came in very, very easily, and it's working very well. So that's very exciting. None of these. It's done all the UVs for me, so. That's great. Another thing that we can see in this file is the use of instances here. So I just thought I would show you how the this object here is only referencing one single object, which is then referenced by all these handrails. So I thought I would do a little teapot trick, because you can't really do a 3D preview without a teapot in it. So I'll select all of that, and then I swap all that with my teapot, and hey, great. So that's super, super, super easy. No need to rebuild my lighting even, and then I'll just swap that back in for my guardrails. So that's really very efficient. It works very well, and it's very precise. So there's a feature that we can really use when we're going to go back and forth if we need to swap out things. Use the instancing capacities of Unreal there. So I'll just save that, go back to my PowerPoint, wherever we were. So, and here we are. Carry on. So managing instances works very well. Once we've got our model in, we will also find some problems that with regards to the way things come in and the actual modeling. So we will probably used to do some modeling, even if we have a file. So here I've prepared this little video screenshot there where I show some problems that have to do with the way things are modeled when for example, in this case with 3ds Max, we use the Pro Boolean, so just to make a hole in this wall, something really simple. And you can see that not only it didn't so in fact, the reason I did this is that a lot of people have asked me, is it okay to do chamfers in Unreal? Is it okay to add this level of detail? Yes, by all means, absolutely. Unreal can take huge amounts of polygons, so that is not a problem. We can really chamfer everything, but it creates problems which we're not used to. So here, if it's done that way, it creates problems, and then you can see this sort of added polygon, this added cut here, which appears in our UV mapping. So that's giving us problems. Even if the geometry didn't come out properly, we could always fix it, but then we've got problems with these cuts in the UV mapping, which will appear randomly. So the proper way of modeling and modeling the chamfers is to keep very close control of our geometry, and it's done with polygon mapping, polygon modeling. So this is something most of you, I'm sure, will be familiar with, but we'll have our loops, and then we're able to do our chamfer properly. And so you'll see that when I'll just fast forward because you don't want to see me model a hole in the wall. But when we do our UV mapping, here we've got control over the way all the faces are properly cut out. And for example, all our chamfers are all next to each other, and that's all done properly. So yes, chamfers by all means, but you need to check your UVs, and you probably will need to do that manually. All right, so that's kind of what it should be looking like, and then I sort of do all. So we'll talk about that again a little bit later. So now, I thought I'd show you another example of this lobby scene that here we've got in front of us. So here we'll jump in the UI again. So lobby, here we go, and I will pause. Okay, so here is our lobby scene. So here I'll just take you through a couple of ideas. Let me just check my notes. So two things. Here we've got, again, the idea of working in instances. So why do that? In our traditional workflow in V-Ray, for example, it would be quite normal to have this entire side of the lobby as one object. In any case, even if we'd modeled the mullions separately, these I would have, personally, I like to work with a clone tool. So I would have this cloned and then cloned as one object. We could even maybe have the entire set of mullions here as one object, and this unfortunately is going to create very big inefficiencies when calculating the light map in Unreal, because when we need to calculate the lighting in Unreal, because it will need to average out or to calculate the lighting over the entire area, and it doesn't really like to do that. The time is going to take to calculate that entire pane of mullions is exponentially higher than by having it separated as single elements like this. So I found that out at the cost of a lot. It took me a very long time to debug this. Well, not debug, to optimize this, and to find it out that it's much better to have lots of objects, and in this case these objects are all referencing the same one. You see that for the whole project I've only got 6 of these frames here, so it's much more efficient calculating the lighting on these instances. Again, here in the restaurant area, I've also referenced in one chair which has been placed using TS tools to place all the instances very quickly and very easily. So that's something to know. As well as that, you will need to decide which objects are static and which objects are movable. So when we have use this workflow, and although here for the lighting calculation I've put it on static, but when you export, you do need to make the difference between your objects which will be static and they will need to be exported as is, and if they are movable, like the chair, which will reference, so we'll have several objects which will reference one, and any of these items which are repeated, it's a very good idea to export them at, so you have to move them at 0, 0, 0, and then you can reference in and then copy them and instance them like I've done here. So that's another sort of strategic um, little decisions to have of how you're going to organize your files for this. So you can see that then it's very easy. All of these objects are just referencing one rather than have them copied over. So that works very well in Unreal. I've used the script TS tools to do that, and we'll reference it. We'll give you the link in the chat in just a minute. Right, so going back, I'll just show you a little bit this screen grab of the scene here, where again, this was from Live Project. I want to really thank again Artefactory and David, Dominique and Eric for working with me on this scene, because that explains the French and the fact that all these layers were very carefully organized, and we have here a small number of objects to deal with, and they've all been properly named with the Unreal conventions and naming conventions, and again being able to organize this file for export. There was a lot of objects to export, and it's a very good idea to keep track of everything. So that's, and again, this export static versus movable. So quick recommendation, go and check out the wiki for the assets naming convention. This is something that was done a long time ago that I personally rebelled against a little bit, thinking, why do I need that? But to be honest, it's worth reading, it's worth knowing about, and if things get a little bit too complicated, worth keeping track of. So, right, we're still on that first quadrant. I know, as I said at the beginning, it's heavily loaded with this. So I'll crack on, though, on our light maps UV. So this is really where we're beginning to prepare our model for working in real time. So for those who don't know, what are light maps? Well, basically, this is it. We've got our diffuse texture, and from this is back in the days, really, where we used to do that in Max. Whether it's using the scanline renderer, or you could even do it with V-Ray, you would create a light map, and this light map combined with the diffuse multiplied over would give us a sense of lighting. So this light map is a texture, just like the diffuse texture we've got here. And for that, it needs to be wrapped. So what is this wrapping? Well, it's the way we have in our 3D model. We've got this UV map, which is this map laid out flat. So what we do is like the reverse of creating a map. It's the age-old problem of creating a map for a round object, which is the Earth, and to see that in 2D. So what we do is that we start with a flat image, and we want to wrap that onto our 3D object. So going back to this idea, this light map needs to be wrapped around the object. Now the problem is that when we use a diffuse texture, that tends to be quite happy being tiled, and we'll do quite a lot of work to make this texture tileable. So we can use box maps or planar maps to indicate how that should be done on our objects. However, the light map cannot be tiled because it's going to be different all around the object. So we need to unwrap it in a way which is properly done, a little bit like for a present. So I can so when we wrap the present with our wrapping paper, then it's exactly the same problem that we're going to have to do, and that's why we use all these unwrapping tools. So finally, channel 1 and channel 2, because we have the diffuse texture, typically the diffuse texture will go onto channel 1 and the light map will go on channel 2. And to add to the confusion, Unreal Engine is going to work a little bit different and with channel 0 and channel 1. So the diffuse will be on channel 0 and channel 1 will be our unwrapped light map UV. Okay, so I hope that's clear. So how do we do that? Well, 2 ways of unwrapping. First one, automatic, and it works most of the time. We've got plenty of scripts to do that. There's the flatten mapping function inside the unwrap in 3ds Max, and that tends to work, and that works great. However, we've got problems, and we need to do everything manually to sort out the problems. So before I carry on, links to the unwrapping 3ds Max script. We've got Steamroller, so that will give you a link of that. We've got this, this is the one I use, UVW Auto Unwrap by Chris Jennings, and TS Tools for all the exporting and, exporting. It works very well. So what are problems with unwrapping? Well, this is it. When we apply the automatic unwrap, when the computer does it, it creates all these arbitrary breaks between the UVs, between the layouts here, and it looks bad. It looks really wrong, and this is definitely going to cause us problems. So this is not good. This is not what we want, and this is what we want. That's going to give us a lot more control. So I've not really got time to show you more about how to achieve this, but we're going to do another webinar about lighting, and hopefully I'll show you more about how to unwrap this. I know a lot of people can't quite get their head around it, because to be fair, it's quite a complicated subject actually. Some people say it's an art form in itself. Anyway, moving on, and this is just a little preview of what we're going to talk about in a very short while, but the light map has a resolution, just like our texture will have a resolution. And we can override with this overridden light map resolution here in Unreal. And I like to think of that a little bit as the DPI for our lighting. So, you know, a DPI, a load DPI, like these blue squares here, will give us a coarse, quick solution, and so that's obviously great for working faster, but the resolution will be lower, so it might not be quite as good. So you can see here when we change our light map resolution here, that when it gets red, it gets much finer, and we want to have that effectively as fine as possible. Obviously, just like DPIs, when we print, a higher resolution is going to make our render times exponentially increase, so to be used with care. Right, so now we can move on to lighting, our second quadrant here, and we're going to have a look at all these new things that we have to get accustomed to when we use Unreal. But before we do that, I just want to do a little bit background, just to explain a little bit what the deferred versus forward rendering system is here. Unreal Engine is a deferred renderer, although it's actually also forward renderer now. They've developed that especially for VR, but the way it works is that it's almost like we would have several renderers stacked on top of each other like layers. So here there's an illustration of what these different renderers would do, and then they're stacked on top of each other like when we would do compositing in Photoshop or After Effects to create the final image, as opposed to the forward rendering, which actually fires a ray from the camera, and when the ray hits a piece of geometry, it queries what's going on, it calculates all the lights and so on, and returns the pixel. So that shows a little bit some of the subtle things which will change for us when we start using Unreal for the lighting. For example, when we have our skylight, here we use the skylight from Unreal, and we have all these different things we can plug into them. So default sky, which is that cloudy sky that comes in when we open a scene. We use HDR and blueprints and sky domes and so on. When we also have environment and the color, the background color, which will, like I said, add on top of the existing skylight. In V-Ray, for example, we can't really have environment color and a skylight. The one will cancel, well, it's effectively the dome light will cancel out the color of the environment, and that will become redundant. In Unreal, it won't. It will, they will both act on the environment. The atmospheric fog also will greatly contribute to the color, to the final color of the rendered image. So that's good to bear in mind also. So we've got a new, our direct light is the sun. There's no sort of special sun like the V-Ray sun. So the particularity of the direct light is that all the rays are parallel. So that will emulate what the sun does, as opposed to a spotlight, which will fan out when we change the angle. We've got the light mass, which is the GI from Unreal Engine. So the light mass, obviously, for those who is still a little bit unclear, the GI is represents the bounced light, the light bouncing from one object onto another, in this case the floor. And again, what's new is the use of reflection probe. So we'll have a little closer look into that, but these very clever little things take a snapshot of the environment and will pre-calculate in the reflection to be applied onto an object. So this really enables us to stay close to this real-time and very fast rendering. Now, they are very quick and very effective, but they also are rather inaccurate. So for that, we've got different techniques when we need accurate reflections. The screen space reflections, which work very well, and then even higher quality and control are the planar reflections. So we'll have a look at that in a sec. So that's all very good technology, but how do we get a clean render? So with the soft shadows, which is what we're really, for architecture, this sort of the staple for rendering. So just a quick look at the settings I've used for this kitchen scene here. I've got a skylight with, so here, first of all, I have used these portals. They're called light mass portals. So I really recommend you use these, look them up if you haven't, but they greatly increase the quality of the lighting solution that we're able to get, and I think they make things a little bit quicker as well. So I've just got a simple skylight, and I've added to it a flat grey cube map. So that's very easy to set up in Photoshop. I'm not going to show you in this tutorial because we've got a lot to go through, but hopefully in the lighting one I'll show you a little bit how to do that. It's very simple. And we've got the so here I've got the intensity set on 10. Quite normal to have the skylight a little bit higher for interior shots like this, but also, as you can see, I've got my environment intensity set to 100 here. I really had to pump a lot of light in to get clean lighting. So, and then these static lighting level scale at 0.75 and indirect lighting smoothness as 0.75. To be honest, I've tried these over and they work for me every time. I don't necessarily always go the indirect quality that high. 8 is really the most I go. I just tend to work within the boundaries of Unreal. Even 4, that works very well for me. Okay, so the light map settings here I've gone over, but just to say over that when we just apply a blanket resolution of 256 or 512 for the whole scene, it tends to not really give us an accurate representation of what the resolution will be, because as you can see, this actually, let me show you that in the UI. Just start up this kitchen scene. Okay, so here we are in this kitchen scene there. So what's really good to understand is how this here, if I just kind of zoom into this coving here, you will see that the resolution is on 264. Okay, near enough 256. And this, although it looks like the same resolution, the floor is on 800. So it doesn't necessarily matter that if the floor was on 256, and then let me just put that floor on 256, you see it's much too coarse. So it's worth really spending the time to go into the scene and look at the objects one by one to make sure you've got the right resolution on it. So again, this is a little bit your DPI and will greatly affect the look and the precision of your lighting. Okay, so I'll save. No, I shouldn't have saved. Anyway, it doesn't matter. We can just carry on. And so static versus dynamic lighting. So let's go back to our scene. Okay, so another thing, the static versus dynamic, we looked at the objects already, but here we need to make this other decision with regards to the lighting. So if I turn my sun off, you'll see that the lighting was actually calculated with the skylight, and the skylight is a static, so that's set on static. Here we've got all static or stationary, which means that the lighting will be rendered is in the GI, and it will be baked in onto our light maps that we prepared earlier. Now, that obviously that can't move because it's been baked in, and this is what happens with our sun here, that I wanted to be able to, well, since I was playing with this great new volumetric fog from version 4.16, I wanted to be able to play with the sun and to have it move around, maybe do an animation for the client and things. So I've got the sun set on movable, which means that it won't contribute to the GI on my scene. So here, if I turn it on and off, you see that it doesn't affect the ceiling or the rest of the room. So this is, again, a good thing to keep in mind in your lighting workflow, whether you want your lights to be static or movable, contribute to the GI or not. In this case, again, it's movable and it doesn't contribute to the GI, and I can turn it on and off. If you want to allow your clients to turn lights on and off, for example, here, this is what we'll see, that if I turn this light off, I will see, you see that there's still the lighting is still baked in, so that looks wrong, and it doesn't kind of look like someone's properly turned the light off. So again, if you want to turn the lights on and off, you need to set it to movable. If finally here, just to say that if you've got your sun set on stationary, then you're going to have this preview everywhere, which is a bit annoying. So it's really in order to get rid of this preview, you just put it on movable, and then you can play around. Okay, great. So carry on. Don't save this time, and carry on. There we are. Okay, so now let's move on to the materials. So the materials, we've got a new node layout. So just quickly to say, in order to get started with this, I would really ignore this, because it's very easy to start with very effective and complex materials with just pretty much what we've got here. So very simple multiply, and to this, as we carry on, as we get more and more familiar, then all of these will be there for us to solve specific problems. So I wouldn't get too overwhelmed by the complexity and the maths. Really, all we need is to get just 3 or 4 nodes, and we can build our own materials very, very quickly and very easily. So this is what I do for to work with the material editor. I try to replicate what we've got in Max. So I create a simple material, and you can see that all these parameters are effectively, for the diffuse here, we've got a diffuse color or a texture map with a multiplier, which is what we've got here in Max. We've got the slot for the map, and we've got a multiplier. Now in Unreal, as you probably know, you can create materials, and then from these you create an instance material, and in the instance material come the parameters that you can play in real time with. So that's what I try to build. If I'm not going to use a map, I just use the multipliers. And these are effectively, so this is interesting to know, that when we put a value into a slot like this, then that value will be from 0 and 1, between 0 and 1, so it's fully HDR, high dynamic range, and it takes, what's a little bit confusing is that in Max, the old color selection is still based on 0 to 256, so here we're sort of getting rid of this problem where everything kind of comes in line with this high dynamic range workflow. Okay, so the other new thing in Unreal Engine is this PBR, physically based rendering materials. Physically based materials, they're not exactly physically based, but what it means is that we have really, we can't quite use our textures the way they did, the way we did, because the old, what's they now call the albedo, the diffuse, is a channel that's got to be void of any lighting. So that's a little bit tricky to do at home or by ourselves. So that's why this is a screenshot from Megascan, where we can buy these textures, and they've been done for us, and we've got the roughness and specular and all these different nodes that work for us. Another way to get these diffuse, base color, or albedo, roughness, metallic, and so on, is to use Substance Designer, which is a lot of the top pro people are using it, and I think it's being used mostly in the CG, in the film industry, and in the gaming industry. So it's it works very well. So we'll have a look at that. And then, so just quickly about these different nodes. We've got the albedo, which is the color information we've gone through already. Metallic, that tends to be an on-off switch, so 0 or 1. And obviously you can break that rule as much as you want, but it's good to know that it's either a metal or not, either behaves like a metallic material or not. The specular, it's good to know that there's always specular on by default, and I found that there's very low values work very well, 0.2, around 0.2, and very small changes make a big difference in the material. The normal, very, very subtle. In architecture, we really gain a lot by working with very subtle normal maps. Now, finally, the roughness I've come to last because, and it's got this special bold and golden color, because the roughness is really where it's all at. I think this PBR workflow, although it sounds a bit complicated, has made things a lot simpler for us. And I think most of the work is really done in this roughness. So no roughness, roughness is 0. It's for a completely flat material like a mirror. And a fully rough is going to be a material which is a bit like concrete or bricks, or which will completely absorb the light. And so it's really giving us this amazing flexibility, which in V-Ray is quite costly to have our glossy reflections everywhere. So whereas here everything will have glossy reflections unless the roughness is at 0, and we can really play around a lot with that. So that's really the lowdown for me for the PBR materials. Another thing is the reflections. So here, going back to this lobby scene, we've got we've got 2 different types of reflection probes. We've got these sphere reflection capture, which work very well. They're very quick, and they are more geared towards maybe reflecting the environment, because they will act like a bit like a dome, and they will take up the environment, the sky, and so on. With our more orthogonal like architectural spaces, we've got the box reflection capture, and this is a little bit trickier somewhat to use, because there's an overlap between the boxes, so that needs to be managed. And of course, in architecture, reflection is always very, very important to us. So I'd recommend you just go into edit and project settings, and you want to go to rendering and increase the size, increase the resolution of your reflection capture probes here. When you increase the resolution, they become much harder to move, because there's a bit of a lag. So maybe keep it low when you're working, but once they're set, do increase the resolution. It makes a big difference. So again, these probes are a little bit imprecise. So for the floor, for example, I tend to always use a planar reflection, and it's very simple. You just drag and drop it in, and place it just underneath the floor, and the floor will just grab these reflections. So you can see they're very precise. They all happen as expected, and they give us a great sense of realism with the planar reflection. So I'm just going to describe very quickly this material which I use for the floor. Again, there's the multiply node and the linear interpolation node. Works a bit like the mix material or the mix map in 3ds Max. So it's just we've got one texture being sampled on top of each other, on top of another, according to a third, which is our alpha. Here you can see that for the metallic and specular, I've got very simple, just one sort of effectively it's a gray color, and then again a little bit more complexity for my roughness, and then the normal, again very simple. So quick tip for the texture: keep the sizes high. We are, because we're in real time and we can move around effectively, we will be able to possibly stick our nose on right on the texture, right on the wall. So 2048 and above, small resolution just won't do anymore. That's probably, so that's where Substance Designer comes in again, because with absolutely no extra work, we can just bump up our output size to 4096. Here we've got 4K textures at no cost. So that's the advantage of working procedurally, where if we had a texture, 1024 texture in Photoshop, in order to bump that up, it would be it would be difficult, if not impossible, in some circumstances. So quick one as well, just to again replicate some of these things we're very familiar with in Max, is this texture tiling, which took me quite a while to figure out, because I was doing something quite complicated, where in fact all we need to do from our texture coordinate node is add a multiply and a constant. So that will take care of our tiling in Unreal Engine. So that's something worth noting if you don't know it already. So very quickly now, because I've nearly run out of time, post-processing is where a lot of the magic happens, like Chris would say. So I'm just going to jump into the interface. All right, I'm already in, so that's great. So I'm just going to show you two super quick tips for the post-process volume here. Okay, just a sec. So yeah, very quick tip here. We've just got our post-process volume. First of all, I'll show you this camera. Really, you want to use this color grading option with Photoshop. So look it up. It's very simple how it works. But if you don't know about it, this is really worth looking at. It makes a very, very big difference for giving great sense of realism to our scenes. Another quick one, I'll keep that on. Quick one is the how to do depth of field in Unreal Engine now with these new Cine cameras. So although in the post-process volume we've got our depth of field here, well, this is not really how it happens anymore. The way we do it is that we use and if any of you are familiar with photography, we will change the aperture. So now there's a little trick, because sometimes the aperture needs to go very, very low. So we've got this minimum f-stop here in the lens setting of our Cine camera. So I just put that really low. I think it won't let me, I'll just put that at 0.2 there. And although that's very unrealistic, it will never, no camera will ever give us that little opening, or that such a wide opening. But you see that when I lower my aperture here, then the depth of field suddenly starts to kick in. Now with this this debug plane, I'm able to, so if I kind of give a sort of slightly stronger focal length, which is a little bit more what would happen in reality, I've got my debug plane where I can really decide where my depth of field, where my focus will be. So if I just sort of focus on this chair here, you'll see that maybe if I increase my aperture to something a bit more reasonable, and then this is really giving me a lovely rendered output here of our kind of everything in focus where we want it, and then the foreground being out of focus in for our depth of field. So I want to save that and back. So again, yeah, we've got some great effects just to go from something quite maybe bland looking to really pump up the contrast and the colors using our familiar Photoshop, and then here our depth of field. quickly, interaction, there's a whole subject in itself, but use the templates for the first person shooter or the VR templates. And then the outputs, just to say that the editor obviously works very well, and this is a level of difficulty and increasing, that if you're a freelancer or you wanted to get into this, there's lots of scope to just create scenes and work up scenes in the editor. In VR as well, if you've got Oculus and you haven't tried the VR editor, do so. It works very well, and I think it's worth playing with as it's being developed. And then we can do high-res stills. So for high-res stills, do look up the NVIDIA NSIL photography plugin. It lets you take pictures up to 60,000 pixels across. So, and you can put all sorts of 360 captures and everything. There you go. So finally, if you need to know more, there's obviously all the documentation. There's also courses that I provide. So you can go on my page and check that out. Great. Well, I hope that was useful, and see you again. I'll hand back to Chris. See you again. Make sure you show up for the lighting webinar next month. All right. Nice to see you. See you next time.